It's not working yet. Oh, here we go. Oh, that's loud. Hi. So I was hoping this would actually work with the PA system in here, but it does not. That's not very good. Because the talk I'm doing is like 90% demos, so I'll be typing all the time. I can't hold this thing, so we'll see how that works out. I'm not. Yeah. Oh my God. Okay. I hope this is not our equipment. I work for Twitter, so this is embarrassing. If so. So this talk is basically showing you. No, let me explain this all later. Okay. So my name is Chris. I work for Twitter. For those of you who don't know, Twitter actually has a VM team. So I used to say we have a small VM team, but that's not true anymore because we grew in size. Like we doubled. We are now 8 people working on the JDK, on the JVM and stuff. We have a bunch of compiler engineers. We have a bunch of GC engineers. We have a few compiler engineers. I'm one of the compiler engineers. Then we have other people working on different things like autotune. What else? Optimizations for Scala, for example. I don't know if any one of you is interested in Scala. Yeah. Okay. That's what I thought. Disclaimer. Earlier this year I was giving a presentation at Scala Days in New York. I don't know how to write Scala. I could not for the life of me do a hello world right now. So don't ask me Scala questions. But I do speak Java bytecode. That's what I do. Okay, so if you're going to tweet about this talk, and I hope you were already tweeting about all the other talks, since you're at the Twitter headquarters, you're kind of forced to tweet. Please add that hashtag. That's my team, so they know that I'm over here and not in the other building where they're missing me. So what is Graal? For those of you who are here to hear about Graal VM, you can leave the room right now. I'm not talking about this. So Graal VM, as you probably have seen the announcements and you might have tried it out and played around with it. Graal VM is a very unfortunate marketing term that confuses people. For a very long time there has been a project called Graal. That's the JIT compiler, right? And then Graal VM is just an umbrella project name that includes Graal the JIT compiler, Truffle, and Substrate VM. Right? I'm not talking about Truffle or Substrate VM. I'm only talking about the JIT compiler, nothing else. Okay, so what is Graal? It's a Java virtual machine just-in-time compiler. Who here knows what a JIT compiler is? Perfect. So I'll just give a nutshell then. It's basically taking Java bytecode while you run your application and compiles it into native code so that it runs faster. That's what a JIT compiler does, just-in-time compiling stuff. So it's being actively developed by Oracle Labs. There's an official OpenJDK project for it. The source code lives on GitHub. And it uses something called JVM JIT. We introduced that in JDK 9 under Chap 243. And it's basically a Java interface where you can plug in an external compiler that is written in Java. And Graal is exactly that. And if you, a little more questions. People know what HotSpot is? Yes. Do people know what C1 and C2 are? Okay, all right. So HotSpot has 2 JIT compilers. One is called C1 or client compiler, and the other one is called C2 or server compiler. You might have heard about client and server before. There are 2 different compilers, and C1 is a high throughput compiler. So it produces native code as quickly as it can so that your application starts up faster. And then C2 is a peak performance compiler. It takes more time to do optimizations, and it produces then peak performance so that you reach peak performance with your application. And Graal, or C1 and C2 are, as the rest of HotSpot, written in C++. Okay? And Graal should be a replacement for C2, and it's written in Java. So if you're going to take away one thing from this presentation today, it is that it's written in Java. And this is very important because the properties of a C++ application versus Java are very different. And this talk is basically mainly to explain to you the differences if you're going to try Graal, that you understand what's going on. It's very important when you run benchmarks or do performance comparisons that you understand why certain things are happening so that you account for them, right? Let's put it this way. Okay, so let's get started. So where do you get Graal? Okay. There is JEP 295, which we did in JDK 9, which is ahead of time compilation. It's basically a small command line utility that takes in class files or char files, and then it calls out to Graal. It's written in Java, by the way, so it just instantiates Graal and asks Graal to compile a bunch of methods, and then it spits out a shared library at the other end. That's how the AOT feature in 9 works. And since it's using Graal, Graal is already in 9, so technically you can use it. It's not really advertised or anything. And so what Oracle did then in JDK 10 with JEP 317 was to basically say, hey, there's now an experimental JIT compiler that you can use. And if you download JDK 10 or later, you have pretty much everything you need, okay? Good. As I said, I'm doing a lot of demos. I'm doing this in the Oracle Cloud. Don't ask me why, but I could explain it to you. It doesn't matter. I cheated a little bit today because I only have 40 minutes. And this talk, the whole talk takes an hour, okay? So I'm kind of in a rush here a little bit. So the way I do this talk usually is, no, that's actually not what I want, because I've done it already. How do you get there? Yeah, this is Oracle crap. It's not actually expired, it's all fine. So the way I do this talk is when I watch talks where people do a lot of demos, the question I always ask myself, yeah, well, this is really nice what you're doing up there, but how long did it take you to make this work on stage, right? So the way I'm doing my talk is usually I go into this interface and start up a complete empty cloud instance. But this takes a while, and then it takes roughly 4 minutes to fire this up. And in the meantime, in this 4 minutes, I talk about myself, how cool I am, and things like that. But so we skip this today because I already started it up. And so we go here, and then we should get a public IP address here. We get this one, and then we log in. That should work. Perfect. And then we make this a little bigger. And we're having 2 windows here because we're going to compare performance numbers later between C2 and Graal. Okay, and as I said, it's completely empty. There's not even Java installed. Okay, so the other thing we need is yum install. We need a Git, so we're doing some Git stuff later. And here, we're going to JDK java.net 11. We're going to download 11. We grab this guy, and then we download it. Okay. Woo, that was quick. I didn't even have to say my spiel here. Usually what I say at this point is we are going to have some awkward pauses when we're waiting for things to download, but not this time. Or at least not for this. We're going to need something else. Maybe I'll, no, not Scala days. I'm downloading the Scala da Capo benchmark, if you guys know that one. You should. It's old, but it works. And it's here. Oops, no, don't download it here. Don't do this. Yes. These are all prep. I'm downloading all this stuff right now because I'm not sure how long it takes. And I'd rather have it now and then later we don't have to worry about it. Excellent. So we have Git, perfect. And we almost have the benchmark suite now, perfect. So we go in here, we set Java home, and we put it on the path, because we're going to use it a bunch of times. And we do the same thing over here. It's really boring watching me doing this, but please be impressed that I haven't made a typo yet. Okay, here we go. Java version, perfect, 11. So, as you know, since JDK 9, we have the module system, right? So there is a command line option that's called list modules. Oops, there you go. And it lists all the modules that the JDK has. It's about 75. And we are looking for modules that are called jdk.internal.vm. Okay, here we go. So there are 3. The first one is jdk.internal.vm.ci. That's JVM CI. That's the compiler interface I was talking about earlier. It's basically the Java part of that API. There's obviously a C++ part in HotSpot as well, because we have to talk to HotSpot. And then the other one, jdk.internal.vm.compiler, is basically just Graal. It's a verbatim copy of the GitHub and stuck in a module. That's really all. All right. Let me go back to the slides then. Oh yes, I'm talking about me right now for 5 minutes. No, I'm not. I'm working on JVMs for a very long time. It's a lot of fun. Okay. Now I work at Twitter. Yoo-hoo. I skipped this. So why am I doing this talk, and basically all the other talks that I'm doing, but specifically this one, I want you to try Graal. And usually I'm giving my talks at Java conferences, but really the big win is with Scala. And there are a bunch of other talks that I do where I show you how much CPU we're saving here at Twitter by using Graal for running our Scala services. So you should check that out on YouTube. It's called Twitter's Quest for Holy Graal Runtime. I might have it later in my talk, I can't remember. I want you to try it, right? Because you can save money, and I tell you, if you are running a lot of Scala code, you will see a CPU reduction. And for us, it was, for one of our services, it was roughly around the 10%. And you know, if you have a bunch of machines, that adds up. So it's a lot of money. Then I want you to try Graal, because I'm sure there are still some bugs somewhere, and I want us to fix these bugs. And then I would also like to improve Graal even. And to do this, we need to throw different code shapes at it, right? I mean, we at Twitter, yeah, we have a bunch of other things, but pretty much all of our services are built on Netty, and then on top of Finatra and Finagle and all this stuff. So like the stack is almost the same. It's just a little bit of different logic at the top. I want all your code, the shitty production code you're running, that would be cool to run with Graal for the various reasons. And then sometimes when I give my presentations, people come up to me and say, well, is it safe to use? Because it's an experimental JIT compiler, right? Does it burn down your data center? I can tell you, no, it does not. We at Twitter, we use Graal for many of our most important and biggest services, 100% in production for more than a year. So the last year, everything you tweeted and saw in your app on the timeline and stuff was running through code compiled by Graal. Then they asked me, how do I use it, right? And where do I get it? And especially the last 2 questions I'm going to answer today. And then sometimes when I actually get people to try it, they usually send me later emails or DM me on Twitter and say, well, you know, I was running this benchmark and it really sucks. And the main reason for this is that they don't understand the difference between what I said earlier, C++ and Java. They're looking at the different metric, they're looking at the wrong metrics, or they're looking at it in the wrong way, okay? But I'm going to explain you all this. Oh yeah, here it is, that's the one. So if you want to know how you can save a shit ton of money, do this. And it's very important when you know, I don't know, I like shiny new things, I don't know about you, but if you want to try this at your company, for example, it's always good that you can go to your manager and say, well, you know, we could save some money. We like money. Okay, back to demo. No, because we've already done it. So how do I use it? You get a JDK with Graal. If you have that one module, then you're good, right? We verified this. And then the only thing you have to do is turn it on, okay? So let's see how that goes. We go to chap 243. Here we are. And then at the very bottom, it tells you how to turn on Graal. Or a JVM CI compiler, really. It could be any compiler. So you unlock experimental VM option because it's still an experimental feature. Then you tell it to enable JVM CI. That only enables the interface so you can access it. It doesn't automatically turn on the compiler. And then you have to tell it, please use the JVM CI compiler. Okay, so all these three will then replace C2 with Graal in HotSpot. You could actually tell it which compiler to use if there would be more than one. But as of today, there's only one, and that's Graal, so it's automatically picking this one. All right, so now we're going to set something that's called Java tool options. And we are going to use, as you all know, the default GC since 9 is G1. And we are going to look at some GC logging output later, and G1 logging output is a little difficult to read, so we're just using parallel for our small, highly scientific benchmarks that I'm going to show you. It doesn't really matter which GC we're using. Then we're using a rather small heap, because we want to see GC activity. And the important part here is that we are setting the maximum and the start size at the same size. And the reason for this is when we are running with Graal, Graal is also being executed as Java code. And it's also allocating memory on the Java heap. And so the heap expansion would be different if we were running with Graal and C2. And then GCs would happen at different times, but we want to eliminate that. We want to compare somehow apples to apples, so we are setting this. All right, and then over here, we're setting this one plus all this stuff. Here we go. And then we do a version here, and it says, okay, I've picked up all these things, and prints version. Perfect. So now, there's a flag called print flags final. And if you notice, it's pretty helpful. It prints all the flags that the hotspot has. And then we're looking for the JVM CI flags. So these are the ones. You see, we've enabled JVM CI, that one's true. We've used the JVM CI compiler, that's true. So everything's being picked up correctly. And I want this one, JVM CI print properties. Here we go. And it prints a very long list of properties. And most of them are Graal properties, and there's a handful of JVM CI properties up here. And I'm specifically looking for this one, JVM CI init timer, because it's printing some output, some logging output when it initializes JVM CI and Graal. Okay, so we are doing this. And since it's a Java property, we decided to pass options to JVM CI and Graal as Java properties instead of -XX options. So we do -D and then equals true and then -version. All right. So there's no logging output. Did we do anything wrong? No, we did not. JVM CI is lazily initialized. It's only being initialized when actually a tier 4 compilation happens. Do people know what tiered compilation is? All right, so when I talked earlier about HotSpot having C1 and C2, the default setup, you always get tiered compilation. And the way it works, you start your application, first your code gets interpreted, which is really slow, and then it gets compiled with C1 at tier level 3. And that means you get native code, but this native code contains code that collects profiling data. And then after a while, you're running this and you collected enough profiling data, it recompiles with tier 4, which is either C2 or Graal, and uses that profiling data to generate peak performance code. And so you're walking through the tiers of your system, and that's tier compilation. So, and I said, Graal is tier 4, and so it's lazily initialized only when the tier 4 compilation is happening. We can look at all the compilations that are happening for a dash compilation for a dash version, and these are all the methods that are getting compiled. The third column, this one here, is the tier level. And as you can see, there's no tier 4 compilation because nothing gets hot enough to actually get to that level. So what we have to do is we have to run a little bit more. And for this, we're going to use, just call it a couple benchmark. There's a dash L that lists all the benchmarks it has, so we're going to use this. And you can see, oh, yep, there's some output. That's cool. JVM CI is getting initialized. There's a class being initialized called HotSpot JVM CI runtime. Then you see some stuff being, like a configuration stuff is being read, some architecture-specific stuff. But it doesn't seem like it's getting to finish, really. And the reason for this is that printing all the benchmarks that the couple benchmark has exits earlier before JVM CI is actually initialized. So we need to run a little bit more. Okay, so we run a small run of a benchmark called Aurora, and then you can see, yeah, okay, there's more stuff being done. Now we can see the HotSpot JVM CI runtime being initialized, took 73 milliseconds. Then there's something called compiler configuration factory. That would select the compiler if we would have specified it, but we didn't, so it's automatically picking up Graal. And then it initializes Graal. HotSpot Graal runtime, bunch of backend specific things. This also looks like it doesn't finish, but the reason for this is that the copper benchmark harness redirects output to files, to standard out and standard error, so we can't see it actually finishing. But it finishes, trust me. Okay, I think that was that for now. Let's go back to the slides. And because before I show you more benchmark numbers, I actually didn't look at my time, so I have no idea where I am. But we have to talk about bootstrapping. That's important. That's the first important thing, the main difference between Graal and C2. Because Graal is just another Java application running in your JVM. It's Java code, right? We haven't AOT compiled it, so we don't have native code for it. So while we compile, while we run this benchmark, for example, while we compile the benchmark methods, Graal itself gets hot and needs to be compiled. That's the bootstrapping part. So, and Graal, while it's doing this, right, it loads Java classes, its own classes, obviously, the VM loads them. It has Java methods, and these methods at some point need to be compiled. So let me show you this. There is a way to do an explicit bootstrap. Don't do this. Okay, this is really only for benchmarking or like presentation purposes. There's rarely a reason to do this manually. As you see, it will take a little bit. Roughly 15 seconds or something, or 20, I can't remember. So what I want to show you, though, is if we're going to run this one and a small version, and we do 3 iterations of the Aurora benchmark run. So it took 17 seconds to compile roughly 2,800 methods of Graal. The way the bootstrap works is it takes all the methods of Java-lang object, and there are only like 5, if I remember correctly, that actually have Java bytecode, and they're very simple, and it schedules all of them for compilation. And while it compiles these simple methods, all the Graal methods get hot, and then they compile themselves, right? That's how it works, and then it's hotter and hotter and hotter. All right, that's what's happening, 17 seconds. All right, let's do this benchmark run of this guy with C2. And then we do the same one over here with Graal. These are the small pauses, and they're not too awkward actually, but Okay, so first iteration, 4.4 seconds, and then we go down to about 4 seconds, okay? So with Graal, you see the first iteration is about 5 seconds, and then we go down to 4, and hopefully again 4. So now, see? Much better compiler. No, just kidding. The benchmark is a little flaky, but so it's, you see there's roughly a 600 millisecond difference on the first iteration. And keep in mind, these iterations are really short. I mean, they're only 4 or 5 seconds, right? And the difference between the time difference between the first on the first iteration are the additional compilations that have to be done for Graal. But as you notice, it's not 17 seconds, right? That's one very important point, because you haven't seen this, but this container that I have has two cores, okay? And as you know, the JVM uses threads and multi-core systems to do GCs in parallel, and there are also multiple compiler threads, right? And when it has the chance to grab these, it uses them to compile stuff. By default, in the tiered setup that I was talking about earlier, when you run, Graal itself, Graal methods are only compiled by C1 and only in tier 1. So it will never get recompiled. And we do this for 2 reasons. The first reason is, since C2 is a high throughput compiler, we want code as quickly as we can. And the second reason is we don't want the compilations for your application to race with the compilations for Graal itself. So that's why we do it this way. And it's perfectly fine. And as you can see, the startup, maybe I should, no, it takes too long. But it compiles roughly 5,000 methods, additional Graal methods in this case. And the additional startup that you get, it's roughly 600 milliseconds. So startup in general is not an issue. And we at Twitter, as I said earlier, we are running a bunch of our services on Graal exactly in that setup. And there are thousands of instances of these services, and we deploy multiple times a week. And we've never had a problem with a startup taking too long or something to time out or anything like this. All right, so brief summary. Bootstrapping compiles a lot of methods, yes, absolutely. About, yeah, if you do it explicitly, like 2,500, but it's roughly actually 5,000. If you start your, whatever, a bigger application up, all of Graal that's being used and gets hot is roughly 5,000. And so you can do it either up front or during runtime. Never do it up front. Really, there's no reason. The only reason why you want to do the explicit bootstrap as I showed it to you is for benchmarking purposes. Then it's valid. And then by default, Graal methods themselves only get compiled by C1. You can change that, by the way, with a flag, but it's usually not necessary. That brings us to the second big item, Java heap usage. And Graal is, who is paying attention and hasn't fallen asleep yet? Exactly, right. So that means that since it's written in Java, all the memory it's using to do compilations is being allocated from the Java heap. C2 mallocs from the C native heap, but Graal allocates from the Java heap. There are pros and cons for this. One advantage of this is, in a container world, and we're all in a container world right now, you have to reserve memory for the JVM to do compilations. And they can get rather big, especially when the methods are large. You do a lot of inlining, loop unrolling, compiler graphs can get big. Sometimes multiple hundred megabytes of memory. The biggest compilation, I mean, it's really, we've seen that once, okay? But the biggest compilation we've ever seen at Oracle was 1 gigabyte. Ridiculous. But you have to at least reserve 300 or 400 megabytes so that C2 can do its job. And you have to think of, there's not only one compiler thread, right? There are usually 2. So, and if you're out of memory in your container, boom, you're dead. With Graal, you can technically take these additional, let's say 500 megabytes of memory and give it to your Java heap. Because when you start up, do I actually have a slide for this? Yeah, I think so. Because most of the compilations that are happening in the first 30 seconds, 1 minute, 2 minutes, right? Then it tapers off. There's still some compilations happening, but the majority is at the very beginning. And at that time, your application's not even fully up yet. You don't, later, yes, when it's fully up, it probably uses all of the Java heap, but at the very beginning, it's not. So Graal can just take some memory, do the compilations, and then when everything's compiled and done, then your application can take the memory. All right, Java heap demo, yes, please, let's do this. We are going to use the same benchmark, and we are logging GC here. So I'm running this with C2. Aurora is a very compute-intense benchmark. It doesn't do a lot of object allocations, as you can see. After the first iteration, we only had 40 megabytes on the heap, and then we collected it down, and then only 32 collected it down. So there's really not a lot going on. And if we do this over here with Graal, then you can already see, yes, there's GC activity. So in the first iteration, we allocate 130 megs, collect down, another 140 collect down, plus an additional 16. So these are all the memory that has been used to compile the methods for the benchmark. Remember, Graal methods are compiled by C1, so they're still using malloc memory, but much, much less because it's not doing so many optimizations. And so this is all for your application, in this case, this tiny little benchmark. And then the second iteration, oh yeah, there are before and after a benchmark iteration, the harness does a system GC to clean up the heap. So these are the ones in between. Second iteration, yeah, we still collect 135 and then down. But in the third iteration, there were no allocations anymore. So after, yes, granted, small benchmark, but after 10 seconds, we're done compiling everything, right? So it's usually not a big deal. And I can tell you from experience at Twitter, we've not seen a problem with this. We've never had, yes, I should mention this because I should. One thing that could happen technically is that you were later in the game actually using all your Java heap, and you have 1 megabyte of memory free because you're all tuning like crazy. And then suddenly a compilation comes in that needs 50 megs. What will happen? Out of memory error. The problem is, since there is no heap isolation as of today, there will be in the future, but as of today there's not, the out of memory error could end up on any thread. If it ends up on a compiler thread, you're lucky because the compiler will catch it and say, oops, sorry, okay, I can compile this. But if it ends up in the application, your application probably can't handle that. So Graal uses Java heap memory, and there's no heap isolation yet, as I said. Most memory is used during startup. That's where most of the compilations happen for your application. Very important memory is being used anyway, right? It's just different from where it comes from. Good. How much time do I have left? 5. Okay, I can't show you this then. I would show you how to download Graal, compile it, and then run with it. Super simple. I've given this presentation before, so you can watch a full version on YouTube. It's basically cloning and then running MX, and it builds a modular jar file, and then that's it. And instead, I can also not show you this one. That would be interesting. I would run a Finatra example. It's called Twitter clone. It would basically show you that the startup overhead is really negligible. It's roughly a second, and that's it. And it's not getting more because once all the compilations for Graal methods are done, they're done, right? So don't worry about this. This one I'm doing because you're Scala people. Oops. All right. So We're going to increase the heap size a little bit, because otherwise we get too many collections. And 2 gigabytes, excellent. And then we run a default size, and we do it twice, of a benchmark called factory. This will take a while. Same over here. 2 gigs. Okay. In the meantime, while this is running, I'll go back here. And then benchmarks. And then there's factory here. And it says, the factory benchmark toolkit for deployable probabilistic modeling to extract topics uses latent devreal allocation. I have no idea what it is. Doesn't matter. It's written in Scala. That's all I know. And funny thing, I gave this presentation once, somewhere in Europe, can't remember. So after my presentation, guy came up to me and said, well, yeah, cool presentations. We are using LDA. I said, what? It's that thing. They're using this in their company. I don't know. Does anyone know what it is? Really? Oh my God. Okay, I don't know. Have you met before? No. Okay, still running. Yeah, these are the awkward pauses, and time's running. You already showed me the 5. What do I get now? Time's over? Time's out 2? Okay, that might work. We're almost done on this side. The first iteration took 47 seconds and then 46. And so we're running this one here with Graal. And we have to wait for it, unfortunately. I could answer a question in the meantime.
You mentioned that you use it for large applications. How much memory can you allocate on top of, what is the overhead of memory for the Graal?
So the question is, what's the overhead of memory because of the compilations with Graal? I'm not sure off the top of my head. So when you turn on print compilation for Graal, it actually tells you how much memory it allocated, because it's pretty simple to do it in Java to figure that out. Peak, maybe 100 megs. I don't think it's more than this, because we don't have a lot of very complicated methods. So I don't think it goes beyond that, to be honest. Okay, well, this is done. And it took 25 seconds to run this thing. I mean, this is ridiculous, right? I mean, this is like 40% improvement or something like this. The reason, as you can see, or one of the reasons, is we did here 53 to 95. That's roughly like 40 GCs, ballpark. And over here, it's 32 to 53, so it's 20 GCs. So we cut the GCs in half. And the reason for this is Graal has a better inlining implementation and additionally a better escape analysis implementation. I don't think we have the time now to talk about escape analysis, but there's like the traditional approach, and then there's something called partial escape analysis. And it's just able to eliminate more object allocations. And this, my Scala friends, is very important for Scala, as you might know. And this is the result. I mean, this is the best benchmark I can find, right? I mean, this is not representative for what we see at Twitter, but it can do that. And this is why you also should try Graal for whatever Scala stuff you have, because it might do this for you. We're seeing this at Twitter. It reduces memory allocations. What's a result of this is that latency, P99 times go down. I have a talk I just gave at Java 1, as I still like to call it, where our P99 times go down by 20%, just by turning on Graal. Okay. I think I didn't forget anything. My summary? I think you know what to do, right? All right, so please, please, please you're the right crowd. When I talk to Java people, it's usually, you know, whatever. For you, it really matters. I cannot tell you how much money we're saving by running with Graal, but it's way more than I get paid. That's the thing I can tell you. Hi, Jack. Yeah, that's it. Thank you very much. Tweet about all the sessions.